Cover is a framework that supports the interplay between requirements analysis and design. Its goal is to integrate models used by the requirement analyst and the software designer to support a continuous interaction between these two actors. This would allow requirements and design to evolve together. Specifically, the requirement analyst uses some form of goal model to identify the goals of the system to be, and the relations between them. The goal model is used to identify the requirements of the system. These requirements are formally specified through some logic. The goal model also allows to identify the tasks that will be implemented in the final system. Each task is associated with an event that occurs in the system when the task ends. The designer of the system uses the events and the requirements specification to produce a model of the system. Note that, during the software development is often the case that the designer, rather than having the finished, complete and fully specified design of the system, only owns at a given time an incomplete and partially specified model of the system. Cover supports the continuous interaction between the designer and the requirement analyst. It provides a unified framework that allows the verification of incomplete models and the interpretation of the obtained results over the original goal model. Specifically, the requirements of interest are verified over the incomplete and partially specified design. Since the model of the system is incomplete, the verification procedure can produce three different values: true, if the property is satisfied; false, if it is not; maybe, if the satisfaction of the property depends on how the incomplete model is refined. Cover uses the results obtained in the design verification to trigger the goal model analysis. The results obtained after the goal model analysis are used by the designer to reason about the impact of her or his design choices over the goal's satisfaction. We now show an instantiation of cover where we assume that the requirement analyst uses a variation of the Tropos modeling language as a goal model framework. The designer uses modal transition systems to specify the behavior of the system. Requirements are expressed formally through fluent linear temporal logic. Let's start from the requirement analysis perspective. We assume that the analyst uses a variation of the Tropos modeling language used in several other works. This version is supported by a tool called GRTool, which can be downloaded from the following link. The requirement analyst uses GRTool to identify the goals of the system and iteratively decomposes these goals until requirements are identified. For example, if we consider the goal model of the bookseller example, which is currently shown in the GRTool, the books available goal isn't decomposed into the goals books ordered and books acquired. This means that, to be available in the warehouse, a book must be ordered and received by the warehouse. Hence, both books ordered and books acquired must be satisfied to fulfill books available. And the final version of the goal model is produced. The requirement analyst formally specifies the requirements of interest. For example, in the page shown on the screen, each requirement is indicated with the keyword assert. The identifier of the goal, for example G11, indicates the goal of the goal model that has been formally specified. Starting from this formal specification of the requirements, the designer produces a model for the system. We assume that the developer is using the tool MTSA to describe the behavior of the system. MTSA can be downloaded from the following link. For example, the designer may produce the model showed in the picture. Using MTSA, the designer can check the formally specified requirements. However, the tool does not give any feedback to the designer about the impact of these results in the goal satisfaction. On the other hand, the requirement analyst cannot give the designer any feedback since the verification results are not evaluated over the original goal model. That is exactly the goal of Cover. To run Cover, it is necessary to download the file cover.jar. Cover can be executed by running the command java-jar cover.jar. It is necessary to specify the file that contains the goal model to be analyzed, the file that contains the design of the system, the process contained in the file that specifies the design of the system that must be verified, a new goal model file that is used to writing the results computed by Cover. By executing this command, Cover runs the model checker and propagates the results obtained by the model checker over the goal model. The propagation is performed by means of an appropriate label propagation algorithm. Additional details can be found in the paper. The results produced by Cover can be inspected using the GRTool. Specifically, using the GRTool, it is possible to open the goal model produced by Cover. By clicking on the following button, it is possible to inspect the results obtained from the label propagation algorithm. For example, let us consider the design D1 that was analyzed by cover. The initial values inform the designer about the satisfaction of the FLTL properties over the current design. All the goals associated with FLTL properties are satisfied or possibly satisfied. Surprisingly, goals G24 and G6 are already satisfied. For example, in the case of G24, the credit card is charged before the book is delivered to the customer. The final values describe the consequences of the design choices over the goal satisfaction. The requirements analyst may manually inspect the results of the goal model analysis to improve his/her goal model. For example, even if the goal book delivered is satisfied, the goal happy customer, whose satisfaction is intuitively related with the delivering of the book, is only possibly satisfied after the goal model analysis. Indeed, the goals book delivered and happy customer are not connected with a make link in the current goal model. Additional information on how cover helps the requirements analyst and the designer can be found in the paper.